we are here at overloading operators. And regarding overloading operators, I took this class from last week. So this is the gradebook class we implemented last week. It had the dynamic field here, the grades array, number of grades. This is the course name, it's a string. Here we have the method which will allow us to add a grade. Here we have a print method. Okay, you have this on GitHub. So if you want to get this source code, if you go to GitHub in the course section, you have this. I just published it while you were taking the test. So if you go on GitHub, let me give you the link in chat. So here you have course 9. You see it, initial course example. And this is what I show you now. So just open a project and you can take this source code, which is what you see here on my screen. Okay, so we had the print info, which is printing the data of the course. We have get name, we have get number of grades. So this is what I added. We didn't have this, the get methods for name, for grades, the number of grades. Here and here I'm returning a copy of the grades. Remember, we don't return the pointer directly. We talked about this. We are creating a copy and returning that. So here we have the class destructor. Here we have the class copy constructor. Okay, and remember, there are 3 situations where the copy constructor is called. One is explicit. So let me show you. So for example, here, let's do a course, OOP course. Okay, and here I would say object-oriented programming. Okay, and sorry, it's not a course, it's a grade book. Gradebook. Okay, and let's call this one OOP gradebook. And here let's add some grades. OOP gradebook, add grade, let's say 10, another 10 and a 9. And now let's print it. So OOP gradebook print. Okay. So right now we should see the grades, and in this way we know this this project works, and we have no issue with it right now before we start. So start without debugging, and here are the grades. Okay, so it's working. Now remember that copy constructors are necessary if you have at least one dynamic field. Also the destructor is necessary because otherwise you will create memory leaks. Okay, and remember that the copy constructor is used in 3 different use cases. One is called the explicit call. So let me remind you this explicit call of the copy constructor. Okay, and this is where you actually create a new object and you say OOP gradebook copy equals the object which you want to copy. So you see here we are defining a new object which is called OOP gradebook copy, and we want to create this object and to take the data from the existing one, which is OOP gradebook. Okay, so this is the explicit call. The other 2 use cases is every time you have a function which will receive an object by value, and anytime you have a function which returns an object by value. Okay, so these are the 3 use cases when you will need the copy constructor. And if you don't implement the copy constructor, you have a default one. Remember the last week course. So this is the copy constructor, the explicit call. And remember, if you don't implement it, you have a default one which will do a shallow copy, which actually will do this. That's why we write the copy constructor. And again, you can implement the copy constructor either with the C++ reference here or either with a pointer. Okay, so I showed you last week both versions. When you have a pointer, this is an arrow. Your colleague, I remember it asked me, so when is the arrow, where is the dot? So again, if this is a pointer, you need to use the arrow here. If this is a reference, they will let you use the dot, like we use this object by its value, like a structure. Okay, so this is what we have from last week. Now let's make this application crash again to understand why we need the equals operator. So at some point here, I will say, hey, let's do another gradebook. Okay, let's say another gradebook, or let's say it's OOP for 2021. Okay, and here I will say OOP for 2021. So here I have another gradebook object, okay, which let's say it's another gradebook for from last year or for this year, depends how you see 2021. Okay, and now I want to copy the OP gradebook into this object. So normally, what do we use to copy something? Equals. So here I will say OP 2021 equals OP gradebook. And you see, if I hit now build, rebuild solution, okay, I don't see any arrow, but if we will run this, debug start without debugging, it will crash, okay? And this is how my screen looks. And if we start this in the debugger, so let's see what's the reason for the crash. You see, even don't allow me to actually stop the command prompt. So if I go here and say start debugging, it will still crash, but it will show you this. And this is what one of your colleagues asked me on Slack. So when you see this image, when you see this wntdll.pdb, you are in trouble. Why? Because actually no one will help you, even the debugger. They have no idea. And generally, this is a memory management issue. So if you see this, if you run your program and you see this, in many cases, 99% of the cases, you have a dangling pointer and you try to delete it. Remember what's a dangling pointer? We covered that last week. So a dangling pointer is when you have a pointer which has an address which 1 second ago was valid, was an address that you created in heap, but now your program has deleted that space there and the address is pointing to something that does not exist and you want to delete it again. And generally, when you try to delete a dangling pointer, which means you try to delete the same address twice, you get this. So if you see this error, you see it's not stopping anywhere and it's saying me that I have a problem here in ntdll, which is a system library. Generally, in 99% of the cases, in many cases, and here I'm speaking about the examples that we will do, we have a dangling pointer and we try to delete that twice. Okay, so keep in mind this image. This is serious error and generally it's a dangling pointer because you see, it's not stopping anywhere in my source code to give me a hint. I have no idea from where this comes. Okay, so when you see this error, remember you have a dangling pointer. So let's try to identify it. Now, if I go back here and I comment this last line and run this again, so stop debugging and debug start without debugging. Okay, and now it's working. So I don't get that crash and everything looks okay. Here, we may think that is related to this. So who's this? This is operator equals. So this is the classic operator equals, which we have used since the first day of coding. Remember, int VB equals 10. So what do we do here? We define a variable and we are using the equals operator to initialize the variable with 10. So this is a classic operator. It's here and it's in all programming languages, and we use this operator many, many times. Now, in this case, I'm using the equals operator to copy the values from this object into this object. Now, a very important distinction. Why this is not the copy constructor? What makes the difference? This is what makes the difference. You see the definition here? So when you write this, this is like, I want to create a new object. You don't have gradebook here, which means this is an existing object. So when you try to copy the values from an object into another object which already exists, this is always equals. When you try to create a new object and get the values from another object, so this is my proof that you try to create an object. I see the definition here, the type and the name of the variable. This is always the copy constructor. So this is always equals, this is always copy constructor. So here we try to copy the values from here to here. So you see, equals, it knows what it needs to do. So equals says, hey, I can do that for you. So it's not saying anything. It's, if I rebuild it, I don't have any compiler error, which means equals knows how to deal with this. Now, how equals is doing that and why we have the dangling pointer, because it's the same story as last week when we didn't have the copy constructor and we used the default one. So you have an object, which is this gradebook. Okay, this is the OOP gradebook. What do we have inside it? So you have what? The name, the grades, which is a pointer, and the number of grades. So I have this string name, which it's a string. Okay, I don't worry about it. And this is the interesting part. I have this pointer, which is the pointer to the grades array. So this is here, this is the pointer at grades, okay? And here I have the number of grades, which is just an integer. Again, I don't need to worry about this one, okay? So this is the integer. Now, when we have created the gradebook, by default, the pointer is null. You see? We just initialize the name using the initialization list, which we can also use, which is mandatory for constants. Don't forget them. Okay. And here we added the grade. So here we talked last week, we create a new array, we add the new grade. So after we added 3 grades here, then in heap, we have this. So this is heap. And in heap, we know that this object, heap, not heap, will have an address where we have the grades. Okay, so here we will have those grades like 10, 10, and 9. And this pointer, we know it's pointing here into the heap. Now, when you say gradebook OOP 2021, OOP for 2021, now we create a new object, which will be here. Let's say this is the copy, okay? And let's name it here. So this is OOP 2021. It will have the same structure, obviously. Okay, so it will have the same structure. It will have the name here. It will have the same pointer. All objects look the same. And here we'll have the number of grades. Now, when you say equals, so this implicit is null based on this constructor. But when we say equals, equals says, hey, I know how to deal with you, to deal with this. So equals will actually use equals. It will use itself to copy all the values from the right side object, which is the source, OOP gradebook, which means from this, and it will copy all the values using equals here. Now, what means equals for the string? Means course name equals course name. Now, equals for string objects means it will copy the string value. We don't need to worry. Now, what means for grades? It will mean OOP 2021 grades equals OOP gradebook grades, which means now that pointer, because copying the value from here, which is the address, let's say £A into here, means that now you have 2 objects which share the same address. Here it is. So what equals is doing by default? Shallow copy. Especially when you have pointers, it will do shallow copy. And this is what we have after this equals. This is the effect. You see this image with the 2 objects pointing here. Now, what will happen here when the program terminates? You have 2 objects on the main stack. These objects will be destroyed. By whom? By the destructor. And because all the values here are on a stack, the first object, so they are destroyed in reverse. On top of the stack, you will have OOP 2021. So when this object is destroyed by our destructor, we also delete this. Remember, we don't want to leave memory leaks. Here it is, delete these grades. And now you have a dangling pointer here. So now the second object on the stack will be destroyed, which is OOP gradebook, but no one announced OOP gradebook, hey, you don't have the data there. You still have the address, but it's not yours anymore. You are a dangling pointer, and you don't have any way to check if you have a dangling pointer. So right now, when you try to destroy this the second time, then you have the wntdll error. So where is the mistake? The mistake is done by equals, which you see it's working by default, but for us, that's the issue. By default, equals will do shallow copy. So if you have at least one pointer in your class, the default equals doesn't work, okay? So that's why the program is crashing. So now you will say, I will never write this, okay? So you say, I will never do this, okay? So I don't want to crash my program. Okay, but at some point, you will have a function which looks like this. Gradebook, create a gradebook. Okay, and here you will say gradebook, new gradebook. Okay, and let's say, I don't know, an empty gradebook. Okay, and you will return it. So this is common. You'll do a function which will create an object for you. Come on, return new gradebook. New gradebook. Okay, so you see, this one will return a new object. Now, how do you get this object from create a gradebook? How do you write the instruction? OOP 2021 equals create a gradebook. You see, this is the way you will call this function. You will call it and you know it will return a gradebook, so you will get that gradebook. Who's this? Is the same one as here. It's equals. So every time you see equals, with the exception of this line, where here is the copy constructor, every time you see equals and you have objects here, this is the equals operator. So you see, even if you say, I will never write this, I think you will write this at some point, because you will do a function which will return an object, and then you will use it, even if it's not obvious, but it's here, it's in front of us. So this is the same equals. Okay, so generally we don't run away from our problems, or we choose to ignore them, we solve them. So how do we solve this issue? How do we make equals work? And here you'll understand what operators overloading means. Now, when we code, we see this very interesting signs, mathematical signs, and we call them operators. For example, I can say VB equals VB plus 20. So here is the plus operator. Now, all these magic signs are not magic. They're actually functions. Remember, in programming, there are only data and functions. And now you can say, and operators. No, operators are a different way to show us functions. So all operators are functions. And what do you think if I will tell you that this is actually, that plus is actually called operator plus? Let's check chat. So we create a gradebook in order to avoid making a dangling pointer in the end? No. What I wanted to show you with a gradebook is that at some point, you will write a function which will return an object. It doesn't matter if it's a new object or whatever you do here, you just return an object. And here in main or in other part of your solution, you will want the result from that function. And you will say your object equals what this function returns, which is another gradebook. So here you will once again call the equals. And if equals is not fixed, again, here you create another dangling pointer. Here, you create another shallow copy. The dangling pointer is created when you start destroying objects. Okay, so here I wanted to show you that even if you don't write this line, you will still encounter equals every time you are, in this case, you have a function which returns an object. And the default version of equals will do a shallow copy for you, and that will create at some point a dangling pointer, and the program will crash. So now the program will crash because of this or this, okay, at this point. Okay, so that's why I was giving you the most common way, and this is a common way. You will have these functions in your programs at some point. Okay, so You see, this is equals, and this is again operator equals. Operator equals. Again, here it is, this one. So let's go back to the operators. Now, when we have started coding, this was one of the simplest programs we ever wrote, right? And I think some of us enjoy that, and that's why we are here. This was very simple. Now, try to imagine that here it's a lie. So they made this simplification just to help us gain some confidence and actually say, hey, it's easy to code until we actually reach C++ or other more complex platforms. So what do you think if I will tell you that this is actually a function, this is actually a function, and the name of these functions are called this operator plus. You see, it has a standard name, the operator and the sign of the operator. And after that, the parameters. So how many parameters does plus have? So how many arguments plus needs as a function?
At least 2, like here we have 2.
Or exactly 2, right? So 2 parameters. Now, what's their type? Int A, int B. You see, in this example, this is an integer, so this is an integer. Okay, so if I understand that actually all the operators are not magic signs, they're actually functions, and they allow us to use them without actually calling a function, it means that equals is operator equals. And how many arguments equals has? Again, 2, the left and the right. So here it's int left, int right, the right side and the left side. Okay, so all these are functions. So actually, instead of writing VB plus 20, can I write equals operator plus of VB and 20? So let's see. No instance matches the arguments list. Argument types are int. Okay, let's start, try to check it. Okay. It's saying there is no operator plus, but let's imagine that this is true, that they are all functions. And in this case, we should write the code like this. So try to imagine the simplest program you ever wrote. At that time, now your teacher will say, hey, if you want to add 2 numbers, we have these special functions, which are called operator and the sign, and you need to use them like this. You see, programming will look very difficult. So that's why operators are actually, let's say, replaced. They allow us to use directly the operator, and the compiler knows how to identify the function, and after that to call the function which is already implemented in the system, in the language libraries. But operators are functions. Remember, in programming, you have data and functions. These are the main building blocks. Okay. So if it's clear for us that operators are functions, it means that we can apply overloading on them. Remember what's overloading? Overloading means to define multiple functions with the same name, but with different lists of arguments. So we know what's already overloading. So what means overloading of operators? It means to define functions associated with the operators in which we teach those functions how to deal with our objects, because they know how to deal with integers, with float, with double, with strings, with chars, but they have no clue to deal with our objects. For example, here equals is doing a shallow copy. So we need to teach equals how to deal with gradebooks. So what I will do, I will go here in the class and I will say overloading operator equals for the gradebook class. Because you see, by default, equals is trying to help, but it's doing more harm than actually helping us because it's doing the shallow copy. So all the functions, all the operators, they have a standard name. You don't need to memorize them. You just need to remember that operator is a special keyword in C++. So you see, when I write operator, it's highlighted with blue, which means it's a keyword like this, like new, like int. It's a keyword in C++. And now you just need to write the sign. So operator equals. Now, we know it's a function. So you open the brackets for the function. And we know that equals, you just need to check this line, or you need to check this line or this line. How many parameters that function requires, that operator function requires? Just check the line where you normally use it. 2. This is the left side and the right side, okay? This is the source and this is the destination. Now, here, remember you are inside the class. You see, I'm defining this operator here inside the class. So if I write here that the equals operator receives 2 arguments, a grade book, so this is the left variable, and another one, grade book, the right variable, right? So in my mind, the left is which one? Is the destination, OOP 2021, and the right side is the one, the object from which I take the values. If you define it like this, you will get explicit type is missing. Okay, so we need to return something. So in this case, do we need to return something? Let's check. Here you have like OOP 2021 equals OOP gradebook. So in my mind, if I see this as a function, this looks like this. Operator equals of OOP 2021 and OOP gradebook. Always do these associations in your mind. So in that way, it will be much more easier to know what function you need to define if you do this association. So do we need to return something here? It's anyone here expecting something? No. So in that case, we can return void here. But we know that in programming, we can also write this. OOP 2021 equals with, and let's create another one for 2022, equals OOP 2022 equals OOP gradebook. So you see, this is a cascade of equals, which means they are always evaluated from right to left, which means the first equals to be executed is this one. So now you initialize OOP 2022 with the value from here, and now the next equals is executed. So you take this value from here and you also copy it here. So in this case, you see, this is like a cascade. So this actually, if I want to simulate it, how it will look like as a function, we have this first operator equals of OOP 2022 and OOP gradebook. And the output from here goes or is expected to go into another equals, which looks like this. It's OOP 2021 equals with what this operator will return. Okay, so here in this case, if you want to allow developers to use equals in a cascade because they are lazy and they don't want to write this, OOP 2021 equals OOP gradebook, and after that to write this on a separate line. So if they want to write this instead of writing this, then equals, you see in this case, needs to return the same value you copied here. Now, remember, OOP program, it's all about control. You have control over others. So if you like this approach, because make this the code much more cleaner, and you don't like this, and you want to force your developers to actually use only this version and not this version, you are in control. When you overload equals, you say void. Because at this point, when they will try to write this, they will have a compiler error because this equals will return a void to the next equals, and the compiler will say, hey, I can't deal with void. So what means copy void? Okay. Now, if you want to allow them to use this sequence, then here you will say return gradebook. Okay. So again, based on how others will use the operator or how you want to make them use the operator, you have the liberty to choose what you should return here, either void, in which case they can copy only 2 objects at a time, or you can return the gradebook. So in that case, it will, they can use it like here or like here. So both versions are now okay. So let's simplify it. Let's, yeah.
Can't we write void and have 3 parameters?
No, equals by definition from mathematics has only 2, like plus. like minus. We know this from mathematics. And a general rule is that when we overload operators, we are not allowed to change the number of arguments. So we are not allowed to invent equals with 3 arguments. Okay. So the main definition from mathematics is still should be followed. So the number of arguments for operators is not allowed to be changed. So that's why we can't. Okay, so right now we have this equals operator. Now I still have a compiler error here. You see it's saying too many parameters for this operator function. So why there are too many? It's like we see 2, but the compiler is saying there are too many. And based on your colleague question, I just said that when we overload operators, we need to stick with their official number of arguments. Plus has 2, minus has 2, equals has 2. So when the compiler is telling you that that operator has too many parameters, it means you pass that limit, which means for equals, which is the official number is 2, it means we have more than 2. So it means we have 3, 4, or whatever. But why do we have more than 2? Because we see 2 here. Where is this function defined? Where is this function implemented? Inside the class. So it's a class member function. What a class member function will always receive, like get grades, get number of grades, get name, print, add grade. What they all receive by default, and we can't change it. All class members. The pointer, this, to which is the address of the object which will call that method. You see, add grade has this object here. So this object address is received here by default, and that address is called this. So this is a function, right? Okay, it's an operator function, but it's still a function. Where is it defined? It's defined inside the class. So what this function will actually receive, it will receive the address of the object to the left of equals, to the destination. And again, it's a pointer. So if you receive a pointer into a function, you can change the values of that object. Again, the power of pointers. And that's why this is a pointer. So actually, in terms of object-oriented programming, when you see equals, is actually, we imagine it like this: OOP 2021 dot operator equals of OOP gradebook. You see, this is the object-oriented perspective. So this is like this object is calling operator equals, and here it's passing this argument. Now, in the end, this equals still has 2 parameters. This is one, it will by default go into here, and it's called this. And the second one is explicitly defined here. So when we will overload equals into a class, you define only one argument, which is the right argument, because here you have this, which is always the left, is always the destination. So this is always the source. Okay, so what do we do now? We copy this course name equals course name. Again, don't mess them up, okay? Like in the copy constructor. This is the source, this is the destination. You don't want to change the source. So that's why another way to define it is to write here a const. Remember the const, it's protecting us from changing these variables here, to change these operators, to change these arguments by mistake. So you can write const if you are not sure which one do you need to change. So if you try to change source, you get the compiler error. But remember, this is the input, and this is what we want to change. This is the left side, is the variable value from here. So let's copy it. This course name equals source course name. This number of grades equals source number of grades. And this is what equals will do by default. This is again the shallow copy, which we will not do. Grades equals source grades. You see, that's why you have the dangling pointer, because this is what actually equals does by default. It's using equals for all the attributes, but for pointers is bad. So we don't do that. So here I will create my own clone. So this grades equals new int of this number of grades. I already changed the number of grades. So, okay. And for int I at 0, I less than this number of grades, I plus plus. And here I will say this grades at index I equals source grades at index I. Okay, so this is where we do the decopy. And now if I have this equals, the program will not crash because now each copy of the source will have its own grades. Now, here we have an issue because maybe this object always asks this. Remember I told you last week, every time you change the address of a pointer, always ask yourself, hey, what's the chance that we already have some grades? So for example, what will happen if I say OOP gradebook equals, I don't know, another gradebook? Do we have some previous grades? Yes, we have them. So when that equals will execute and you do this, what this will generate? A memory leak. So every time you change the address of a pointer, always ask yourself, what's the chance that we have some previous data there? Will that generate a memory leak? Do you need that data anymore? And so on. So here, in order to prevent the memory leak, I will do this, delete these grades. Okay. So in this way, you avoid also the memory leak if there are previous grades. If this pointer is null, nothing bad will happen. We just ignore it. Okay. So you see, I have implemented equals here. Based on my decision to return void here, you see I have a compiler error saying that no operator equals matches this operand's gradebook and void. You see the error? Always read the error. And it's saying you have a gradebook here, sorry, here, and to the right, you have void. Where that void comes from this equals. They are always executed from right to left. This is the first equals to be executed, returns void, because this is what we decided here. And now this equals can't work. So in this case, our colleagues, they can't use a cascade. Okay, now if they want to copy OOP gradebook into OOP 2021 and 22, this is the only way they can do it. Okay, line by line, they need to copy. Okay, so in the next weeks, maybe we'll do an example and I'll show you. But here, if you want to allow them, you just do this gradebook, and here you return the source, or you return this. Okay, now if you return this is a pointer, and here you say you return an object. So how do you get the value at the pointer? Okay, like this. So in this way you return. So this works either with return asterisk this or return source directly, because you need to return a gradebook, not a pointer to a gradebook. But in our case, we said, hey, we don't want to return anything. So they need to copy each object in pairs. Okay, so this is the equals operator. Now, let's try to use this logic of overloading operators to see if we can overload other operators, for example, but equals is necessary. Here with equals, there is this strange scenario when someone by mistake, and this is a mistake, will write this. Let me show you the mistake. They will say OOP gradebook equals OOP gradebook. You see, when someone writes this, it's like copying the same object over itself. And from the syntax perspective, it's okay. So if you want to do this thing that does nothing different or is not changing anything, you just copy the same object over itself. It's like writing VB equals VB. It's a nonsense. But let's say by mistake, someone can write this. What will happen? If you by mistake do this, it will start executing this equals operator. It will copy the same name over the same name. It will copy the same grades over the same grades. And here it will do what? Delete these grades. But remember, source and this are the same because someone wrote this. and now you just delete your grades, and now you create a new array, and now you want to copy the values from source. Yeah, but you just deleted them, and here the program will crash. So in this case, in order to avoid this scenario when someone by mistake, so I don't see any reason someone will write this only by mistake. This will crash your program. It's actually creating a dangling pointer here, and after that you try to read from it, so it will crash. So in order to prevent that, because I don't know, maybe you or others will write that mistake, always check the pointers. So before deleting these grades, check them. So if this grades equals with source grades, remember you are checking the addresses. It means you have the same object, okay? Is the same object. Why? Because this has the same pointer, the same address here in grades as the source. So it means it's the same object. So in that case, we can, I don't know, exit or return it, or so it's the same object, else we copy the values. But generally, if you reach this is the same object, you should return, okay? Because it makes no sense to copy values from you into yourself, okay? So what's the sense of doing that? I don't know, just do some computations and that's it. So watch out for this kind of stuff, because by mistake you can write that line. Okay, so this is equals and it's mandatory, and that's why we start overloading operators with equals, because it's mandatory. So now let's try to see if we can overload plus. It will be cool, right? So instead of writing add grade, let's say I want to write OOP 2021. Instead of add grade, I want to write OOP 2021 equals with OOP 2021 plus 8. Okay, so in this case, I want to make plus to know what to do with this integer, actually to add it inside the grade. So how do you know which function do you need to overload? Always start with this. Always write this line, and now check the compiler error. And you see the error is actually giving you the method signature. It's saying there is no operator plus which matches these operands, and it's saying gradebook and int. So you see, it's saying there is no function plus which has two parameters, the first one to be a gradebook and the second one an integer. So right now you know which function you need to overload. So I will again go here into the class, and I will say operator plus. I know I'm inside the function, I'm inside the class, so I know that this object OOP 2021, which is a gradebook, is received by this, because again, I imagine how this will look like this, of 8. You see, this is how it will look like if I see it as an object dot function and some arguments. So I know that this value will be received here and is this. So the only argument that I need to write is this integer. So here I will say int grade. Okay. Now, what do we need to return? Again, check the line that you want to write in order to use the operator. So you see, this is the operator plus, and this needs to return something, a value that, who's this? Equals again, you see equals again, like here and here. Equals needs a value which wants to copy it over here. What's this? A gradebook. So what plus needs to return in order to be able for this equals to work? A gradebook. So based on that, I will say, hey, plus will return a gradebook. So gradebook operator plus int grade. Okay. And now you see the error disappear. So in that way, you validate if you define the signature, the method signature correctly. Okay. Now, a common mistake with plus, minus, multiplication, and division is to forget the math from, I don't know, from first class or second class, okay, in the primary school, first year or second year. So remember that mathematical operators like plus, minus, multiply, and other, they don't change the operands value. So when you do VB equals VB plus 20, plus is not changing VB, equals is changing VB, because in the same time I can have int VB2 equals VB plus 20. So if initially VB is 10, you will say after this line that VB2 is 20, but VB is still 10. Now here you say VB is 30, but not because of plus, because after this function, VB is still 10. Responsible for making VB 30 is the equals here. Okay, so remember, plus, minus, multiplication, division, they don't change the operands value. They just return the new value, the result, and maybe here you have an equals, which this one is responsible for changing OOP 2021, because it will take that new gradebook, which is changed, and now you change it. So how do we do that? So let's say this is a mistake. To say this, add grade, because now you are changing OOP 2021. So this is a mathematical mistake, let's say. Okay, you are changing the operands value. So always in plus, minus, multiplication, division, always create a copy of the object. So do we know how to create a copy of the object? Yes, we know from last week. We know that the copy constructor is doing that. So gradebook copy equals this. Again, this is a pointer. It's a gradebook asterisk variable, and this is a gradebook value. And the copy constructor expects here not a pointer, but an object. So if you have the address of an object, how do you get the object? With asterisk, right? This is the syntax for pointers. If this is a pointer, asterisk to that pointer returns the value there in memory. So gradebook copy equals this. You see, I'm creating a copy, and now I'm changing the copy. So copy add grade. And now the copy has the new grade added by plus. And now I'll say return copy. Okay. And this is plus. We already had add grade here. Okay. It's from last week, which is adding a grade. So this is plus. Okay. You see how I have deduced the signature. I don't need to memorize it. So let's try another one. Let's try to see if we can do plus to be commutative. For example, I want to say OOP 2021 equals 9 plus OOP 2021. So right now, again, I'm checking the error, and it's saying there is no operator plus which matches this operands type. And you see the first one, it's an int, and the second, it's a gradebook. So this time, this function looks like this. Operator plus of int and the gradebook. So if I try to implement it as before inside the class, like here, again, you will say, don't write the gradebook because you get it by default, and write the int. Yeah, but in that case, I will have the same signature as here, right? So when you have operators in which the object which is related to your class is the second and is not the first, you see here it was the first. Okay, that was the signature. Operator plus gradebook and int. This was the signature of this version here. And here is the integer. Remember, you always receive this as the first argument in the list. You can't say to the compiler, hey, I know it, but make this to be the second one. You can't. So when the operator you want to overload has a signature in which your object type is the second, is not the first, then the only way to implement it is by a global method. You can't do that in your class because you get this by default. So I will go here. This is the global space. So here I will say operator plus. Okay. And now you don't get anything for free. You don't get this. So everything you write here is what you expect to receive. Integer grade and gradebook. Okay, so this is the signature. Again, what do we need to return? Always check if you have something to the left of this operator. So you see, you have equals here, expecting another grade book. No, you don't need to have that function. Now we are in a, let's say, lucky position because we already have the function from last week. But if you don't have add grade, what do you need to do? You need to do all this stuff where? Here in the plus. Okay, but again, if you have spare time, do a function for that. Okay, because maybe you will need that also in another context. Always do functions. Okay, you never know, maybe you will need that the second time or a third time later. So if you have the function, it's much more better.
Teacher, but
Yeah.
why are you writing the function operator plus right now outside the class?
Because you see, the signature of the plus function from here has the first argument as an integer. Now, if we define a method, any method here, int something, what do we get always here? We get this, right? Because this is the rule. Every time you define a class member function, in order for someone to call this function, they need an object. They need to say, oh, P 2021 call dot something, right? And by that, you get here an argument by default, which looks like this. Gradebook, this. You always get this one, even if we don't write it. You see, all these methods get that. Like get grades, get number of grades. This is the rule. All your class member functions will receive the this pointer. But you see, this is always the first one. So it's always here, the first. Now, if I define this operator here, okay, it will say to me, yeah, let's say it's returning void just to show you. It will always say to me too many parameters, you see? Because I will also get this here. This is entering here. So it's actually 3 arguments. Plus here has 3 arguments. And the only way to actually say, hey, I don't want this here to be the first one, I want to associate this with gradebook, is that you can't say, hey, let's consider this to be this. You can't say that to the compiler. So if your operator has a list of arguments and the object is not the first argument, is the second, the only way is to go outside the class, because outside the class, you don't get any this. This is what you get. This is a global function. This is actually a C function. This has no relation with C++ whatsoever. It's C++ because we are using objects here, but it's C here. Okay? That's why.
So if we use it in the class, we are always going to have this pointer, right? In addition.
Exactly. You will always get it. And by that, you plus will have 3 arguments. And now you will say, okay, I know, because plus will have only 2. So which one do you delete? Because this cannot be deleted. You can't say, let's ignore this because you get it for free. And if you remove this one, and here you have this is the previous plus, which is a gradebook plus an integer, right? And we need a version with an integer plus a gradebook. We need it for this one. And you see the integer is the first operand from left to right. So in that way, the only way to do it, to escape this, is to define the function outside the class. And
so right now,
yeah,
the grade plus the grade book works, right? The first instruction.
This one here.
Yeah, like if you go down and we have.
So this one works because now the compiler has a version for a plus operator, which knows how to add a gradebook plus an integer, which is our version from here. Okay. And this, you see this here is that gradebook from the left of plus. And now we want to teach plus to also add an integer plus a gradebook, because based on overloading, these are 2 different functions. You see it? This one has a gradebook as and an integer, and this has an integer and the gradebook. And what overloading tell us? You can define multiple functions with the same name, but with different arguments list. The first criteria is their number. but in this case, they have both functions. They have the same number of parameters too. And in that case, their type from left to right will make the difference. So here you have gradebook and integer. Here you have integer and gradebook. And it's obviously the lists are different. Okay.
Yeah, but we could just write the first way, right?
So when you overload operators, it's your decision which operators do you want to provide. So if you say, hey, if you want to use my class, my gradebook class, and you want to use plus, this is the only plus that I will offer you, a gradebook plus an integer. And now you overload other operators. So you are always in control. You decide which operators you want to overload, okay? So you can stop here. But if you also want to provide the commutative version, which actually means we know that plus is commutative, which means this plus this should also work in reverse, like an integer plus a gradebook. Then if you want to provide this version also, then you need to overload a different, to provide a different overloaded version. And this is what I want to show you, that sometimes if you need to overload an operator and the first argument of that operator is not your class type, the only way to overload this version is to actually go for a global method. Because otherwise, if you define it here inside the class, you get this as this here on the first location. Okay? So operators which have two arguments or one argument, and that argument is a different type than your class, you can overload that operator only by a global method, like this one. So plus here again needs to return something. And again, I see equals, which is expecting a gradebook. So here I will again say gradebook operator plus. Now, because I have the previous one, why not using it? So here I will say return, but this works because I already have it, because otherwise I need to do the same stuff here. And here I will say return gradebook plus grade. You see? Because I have this one. Now, if you don't have this operator, then in that case, so if you don't have the other version, then you need to do the same stuff again, which means you create a copy, gradebook copy equals gradebook, the one that you receive here, and then you add the grade, copy, add grade, grade, and then you return the copy. But because we already have that, I can't have two returns here. So let's comment the second one, but you can rewrite the same stuff you did here. You see here, I get a copy of this object. Here, I get a copy of the implicit this reference that I got here of the this object. Okay, so this is the idea of overloading operators, okay?